Hello grade 9, welcome back. This is video lesson number 4 and I am Madhu Badke. We will continue with chapter 1, that is number system. In this video lesson, you will learn about various operations on real numbers. By the end of this lesson, we will be able to add, subtract, multiply and divide two real numbers. Radical number. We have already learned that a number which cannot be written in the form P upon Q is called as irrational. Examples of irrational numbers are root 2, root 3, root 7 and so on. In general, root A, where A is a positive real number. And this symbol, the square root symbol, is called as radical, and therefore root A is called as radical number. If root A is equal to B, then we can write that A is equal to B square. You can check using an example. Root 4 is equal to 2. Then 4 can be written as 2 square. The idea of square root of a number can be extended to cube root of a number or fourth root of a number. Likewise, nth root of a number, where A is a positive real number, and all these symbols, cube root, fourth root, fifth root and so on, nth root, they are called as radicals. So if nth root of A is equal to B, then we can write A as B to the power n, where n is called as index. In this chapter, we will only learn about the operation of square root numbers. In case of square root, the index number is 2, which is omitted. Here are some properties of radicals that we will be using in our operations with real numbers. You can add one more property here, that is root A into root A is equal to A, which you have been using in your lower classes. Let us understand these properties one by one. Root A into root A is equal to A. For example, root 3 into root 3 can be written as square root of 3 into 3, which is equal to square root of 9, and that is equal to 3. You can take any other example and you will be able to show this result. The second property, root A into root B is equal to root AB. Example, let's take root A as root 2 and root B as root 3. Then the product of these two irrational numbers can be written like this: root A into B, that is 2 into 3. So this is same as root 6. Root A upon B can be written as root A upon root B. So if I have a number root 7 upon 6, the radical can be separated with the numerator and denominator. Fourth property, root a plus root b into root a minus root b. This is like the expression a plus b into a minus b. So this identity is a plus b, a minus b equal to a square minus b square. So we can use the same thing. This becomes root a square minus root b square, which is root a square is root a into a, which is a, and root b square is root b into root b, which is b. Root a plus root b into root c plus root d. Multiply root a to each term of the second bracket. So root a into root c plus root d plus root b multiplied by every term of the second bracket, root c plus root d. So this is same as root ac plus root ad plus root bc plus root bd. The sixth property, root a plus root b whole square. This is same as a plus b whole square equal to a square plus 2ab plus b square. Use this identity to expand this. So root a square plus 2 root a root b plus root b square. Root a square is a. This is 2 times root ab plus b. Now using these properties, let us find the product of two irrational numbers, root 8 into root 18. We can write this as root 8 into 18, which is equal to, now find the factors here, 2 into 2 into 2. 18 is 2 into 3 into 3. So grouping identical terms together, 2 into 2 into 3, and that is 12. You could have found the product. 8 into 18 is 144, and we know that square root of 144 is 12. Let's find the product of 2 plus root 7, 3 plus root 5. Multiply the first number with both terms of the second bracket. So 2 times 3 plus root 5 plus root 7 times 3 plus root 5. So this is equal to 6 plus 2 root 5 plus 3 root 7 plus root 35. This will be the final answer of this product. We cannot add any of these terms. Here you have a rational number. This is irrational, irrational, and irrational. But these numbers cannot be added unless you convert them into decimals. So we leave the answer till here. Let's find this root 2 plus root 5 whole square. This can be written as a square plus 2ab plus b square. where a is root 2 and b is root 5. So substituting root 2 square plus 2 root 2 root 5 plus root 5 square. Root 2 square is 2 plus 2. Root 2 into root 5 can be written as root 10 plus root 5 square will become 5. Now we can add 2 and 5. That gives us 7 plus 2 root 10. 3 plus root 3 into 3 minus root 3. This is of the type a plus b into a minus b. And that can be written as a square minus b square. So this product can be written as 3 square minus root 3 square. Your a is 3 and b is root 3. This is 9 minus square root of 3 square is 3. So that is equal to 6. Now try adding an irrational number like root 2 to a rational number, say 21. We know that root 2 value is 1.4142 and so on. The digits continue because this is non-terminating, non-recurring. Then on adding this irrational number value root 2 plus 21, we get 22.4142 ... which means this number is still a non-terminating, non-recurring. So this addition of irrational and a rational number is irrational. Let's now try subtracting an irrational number and rational number. So let's consider an example. Pi minus 2. Pi is an irrational number. Value of pi is 3.1415 ... The decimal digits are repeating and non-terminating. So when we subtract 2 from this number, the result will be 1.1415 ... which means the difference is an irrational number because it is non-terminating, non-recurring. So what do we conclude? When we add an irrational number to a rational number, or when we subtract an irrational number and a rational number, we find that the result is always irrational. So we can conclude the statement: the sum or difference of a rational number and an irrational number is irrational. Let's multiply a rational number 7 with an irrational number root 5. 7 into root 5, writing root 5 in its decimal form, 2.236 ... You get the product as 15.652 ... which means this number, this product is non-terminating, non-recurring. So this product is irrational. Let's take another example where we divide 7 by root 5. So we are dividing a rational number by irrational number. So 7 divided by 2.236 will give us 3.1304 ... which means this quotient is also an irrational number. So we can conclude that the product or quotient of a rational number with an irrational number is always irrational. Now write down two irrational numbers whose difference is a rational number. Let's take two numbers, 2 plus root 5 and minus 2 plus root 5. These two are irrational numbers. We have shown earlier that the sum of rational and an irrational number is always irrational. So let's find the difference. The difference of these two numbers is 2 plus root 5 minus 2 plus root 5. Opening the bracket, the signs of the terms inside the bracket will change. So we will get plus 2 minus root 5. Plus root 5 and minus root 5 becomes 0. So your answer is 4, and this number is rational. Let's find two numbers such that their difference is an irrational number. So let's take 2 plus root 5 and 2 minus root 5. The difference of these two numbers, 2 plus root 5 minus in bracket 2 minus root 5. Change the sign when you open the bracket because there's a minus sign, so minus 2 plus root 5. So in this case 2 minus 2 becomes 0. Root 5 plus root 5 will become 2 times root 5. Now this number is an irrational number. Now let's find two numbers such that the sum is a rational number. Two numbers that are irrational. So let's say 5 plus root 3 is one number and 5 minus root 3 is the other number. So the sum will be 5 plus root 3 plus 5 minus root 3. Root 3 minus root 3 becomes 0 and 5 plus 5 will give you 10. So this number is a rational number. Now let's find two irrational numbers such that the sum is an irrational number. For this we will take 2 plus root 3 and the second number be minus 2 plus root 3. So when we find the sum, 2 plus root 3 plus minus 2 plus root 3, this will give us 2 minus 2, 0, and root 3 plus root 3 will become 2 root 3. This is a product of rational and irrational number, so this will be an irrational number. So we have seen that the difference of two irrational numbers can either be rational or it can be irrational. Let's try to write two irrational numbers such that the product is a rational number. For this, let's take examples 2 root 5 and multiply it with another irrational number 3 root 5. So 2 into 3 into root 5 into root 5. We know that root 5 into root 5 is 5. So 5 into 3, 15. 2s are 30. So this number is rational. Now let us find two numbers such that the product is an irrational number. For this, let's say two numbers are root 3 and root 2. So finding the product, this will be under root 2 into 3, which is root 6, and this number is irrational. Write two numbers such that their quotient is rational number. Let's choose 5 root 3 as one number and the other number be root 3. When we find the quotient, we divide one number by the other. So 5 root 3 divided by root 3 will be 5, and that is a rational number. Now write two irrational numbers such that the quotient is irrational. So let's take two examples like 3 root 15 and 3 root 5. So when we divide 3 root 15 by 3 root 5, 3 and 3 gets cancelled. This can be written as root a upon b. So that is root 15 upon 5, and this gives us root 3, which is irrational number. So what do we observe? What can we conclude? When we find the product of two irrational numbers, they can be either rational or irrational. When we find the quotient can be either rational or irrational. So if we add, subtract, multiply or divide two irrational numbers, the result may be rational number or irrational number. With this, we come to the end of this video lesson. Your assignment for today is exercise 1.5, question number 1 and 2. Goodbye.